Our next reading, in fact, is going to be in large measure, actually not a reading, but merely a series of notes on Aristotle and an introduction to the system of the world of Aristotle. Now, here in the opening lecture, I want to see just an opening video, I want to see just a few words about Aristotle, the importance of Aristotle, and some special difficulties associated with him. Aristotle, as your book tells you, was born in 384 and died in 322 before the Common Era. He really lays out a system of the world and a lot of the concepts that we use in the sciences even up until today. He was an incredibly systematic thinker, together with Leibniz, perhaps one of the most intelligent human beings in the history of humanity. His accomplishments are really quite exceptional. Now, I want to share with you a few issues. One of the problems, once you understand Aristotle's theory of motion and natural motion and violent motion, is called the problem of projectiles. Now, in the problem of you may wish to watch this video a second time after you go through the notes. Now, the problem of projectiles is essentially this: when I throw an object, after that object leaves my hand, its natural motion, if it is something like a stone, would simply be to fall. Yet we all know that it continues to move horizontally for an extended period of time. Why does the object continue to move after it leaves my hand? That may seem like an innocent question. It is not. Aristotle doesn't have an answer to that question. I want you to think about it. Eventually, his attempted answer was that the world is a plenum, there's no empty space. And so the object moving forward creates kind of a threat of a vacuum behind it. And so there's created a sort of temporary vortex which propels the object forward for some time, but which eventually breaks down. That is probably the worst idea Aristotle ever had. Other and later civilizations came up with the idea of an impetus, some sort of temporary force that comes to reside in the object. And this was held up until the scientific revolution. We'll see the answer to this problem when we get to Descartes. But I want you to think about this. The problem of projectiles, built into this, is one of the most important lessons that I teach in Introduction to Philosophy. I don't discuss the logic of Aristotle in my notes on Aristotle, and we don't read anything on it. I would like to say just a word about it. Aristotle basically created logic as an abstract discipline and brought it to a point where it essentially stagnated for 2,200 years. That is interesting. In other words, nobody for the next 2,200 years knew how to improve on the logic of Aristotle. It is extremely difficult to think at the level of abstraction that Aristotle was thinking about. Everybody else was thinking in terms of arguments. They may note that one argument is like another. For example, if I were to say all whales are mammals, the orca is a whale, therefore, okay, I'm sorry. All whales are mammals, all mammals have lungs, therefore all whales have lungs. And if I say all monkeys have tails, the colibri is a monkey, therefore the colibri have tails. You may recognize that the first argument is some way similar to the second. You can find that in other civilizations. But what Aristotle did is he began thinking directly on that argument. He gave it even a name, which in the medieval version of it was called Barbara. And we are studying strictly the terms of the structure and thinking in terms strictly of a structure. So he's no longer thinking about the argument itself, but only about structures, and he names them, and he creates a complete system of an understanding of the structures of reasoning within certain fairly narrow parameters. Logic begins to move forward again around 1850 and moves forward very fast for the next 60 years, basically underlying the development of contemporary information technology once that happens. So his work in logic is extraordinarily important. There's another point that I want you to capture that is an extremely important part of Aristotle. When you look at a system of the world, and what the concept of the world is, ask yourself, what is the shape of the earth? The shape of the earth for Aristotle is spherical. It is, to simplify a little bit and put it into two dimensions, it's round. There's a myth that you probably learned in high school, and I want to come back upon this a few times. That myth is, before Columbus, people thought the world was flat. Poppycock. We have understood for a very long time that the world is round, not flat, or spherical if you want to be more precise. The idea that the world is flat before Columbus was a myth that was created in the 19th century and is simply a falsehood. Yet think about this. That is probably even in your high school textbooks. All right, it's repeated quite frequently, and yet is completely mistaken. It comes ultimately from a novel by Washington Irving, The Life and Voyages of Christopher Columbus from 1828, which was simply a novel, and he misrepresented what took place at the court of Queen Isabella. And later, another person who should have known better, an authentic historian who just basically messed it up, Andrew Dixon White, wrote on this, and he treated the story of Washington Irving as if it were fact, when in fact it was purely fiction. And in fact, at the court of Queen Isabella, the question was the size of the Earth. Columbus thought it was roughly 1/3 of its actual size. The other scholars at the court said, no, it's about 3 times bigger than that, basically having the right answer. The Greeks already knew the size of the Earth with a bit of simple geometry and measuring shadows cast at particular times of the year. They were able to figure this out. Um, and so essentially, Columbus was perfectly wrong, and Isabella was perfectly irresponsible to let him take 3 ships and men and sail to the west, thinking that they would reach China. Of course, if there were not the Americas there, these men were dead. They never would have gotten to the east. They never would have gotten to China. It was only bumping into the Americas which saved their life. So it's a bit of a lucky mistake, one may say, or unlucky if you think of in terms of the Native Americans. Nonetheless, the idea of Christopher Columbus boldly knowing that the world was round where everybody else thought it was flat is simply nonsense. You can check that out in several different ways. The names I just gave you is one way. Actually, Wikipedia, I hate to refer you to Wikipedia, but it has a nice little article on this. Last time I checked, simply the myth of the flat Earth. Just type in myth of the flat Earth in Wikipedia, and you will be able to have pretty good information on this if they haven't changed it since the last time I read it. Finally, the last thing that I wish to note with regard to Aristotle refers to Zeno's paradoxes. I indicate, actually there's 2 things I wish to still do with Aristotle. I indicate with Zeno's paradoxes that there's some mathematical problems if you try to describe motion with geometry. And the Greeks were aware of these problems and had no idea of how to solve them. You'll see this discussed in the notes. And I here want to say verbally what Zeno's paradoxes are. They're a very simple thing that motion is impossible, because if somebody is in point A and wishes to go to point B, before they get to point B, they have to go half the distance. And then they would have to go half of the remaining distance, half of the remaining distance, half the remaining distance, half of that distance, and so on. And so they would never actually get to their destination. Seems like perfectly good reasoning. Where is the mistake? Or you can give a second form of Zeno's paradox. He has 3 forms. Before they get to their destination, they have to get halfway. But before they get halfway, they have to get a quarter of the way. Before they get to a quarter, they have to get to an eighth. Before they get to an eighth, a 16th, and so on forever. So you actually can't get moving at all. It's hard to see where the mistake really lies when you think about this. Finally, the third form of Zeno's paradox is a race, an imaginary race that Zeno describes, called the race between Achilles and the tortoise. The parameters of the race, simplified to use modern measurements, is simply this. We're going to give the tortoise a 100-meter head start over Achilles. And we're going to say that Achilles can run exactly 10 times faster than the tortoise. Probably be even more than that, but that doesn't matter. Now, under the parameters that I've just set up, once Achilles has run 100 meters, the tortoise will have run 10. Once Achilles has run 10, the tortoise will have run 1 meter. When Achilles has run 1 meter, the tortoise will have run 1/10, and so on. So it appears that Achilles will never catch the tortoise. Long story short, the answer to Zeno's paradoxes is calculus. If you try to solve motion problems with geometry, there is no answer to Zeno's paradoxes. You have to learn to work with infinite sums. And the interesting point is, sometimes you can sum an infinite number of positive elements, yet their sum is finite. For example, with the Achilles and the tortoise example, which will bring it out the most clearly, when you add together 100, 10, 1/10, 100th, 1,000th, and so on forever, they will tend to exactly 111 1/9 of a meter as a limit. Hence, Achilles will catch the tortoise at 111 to 1/9 of a meter. Now you might think automatically that because you're summing positive elements and there's an infinite number of them, that their sum itself would be infinite, but it's simply not the case. And with modern mathematics, we now understand it. As you go through Aristotle, I want you to keep in mind as well that he's not necessarily as difficult as he seems. Rather, sometimes he's just creating conceptual tools that are very important, but sometimes those conceptual tools are actually fairly simple. When he talks about something's material cause, you may seem like you're dealing with a very complex and difficult notion, but he simply means the materials that go into the composition of the thing. So sometimes don't read too much into Aristotle. He can be deceptively simple from time to time. All right, that brings that to the end for Aristotle.